You're given that vector OP is minus 4, 3, 5, and vector OQ is 3, minus 4, 2. A. Find a unit vector which is parallel to the vector PQ, and B. Find a vector with magnitude 5 units parallel to PQ. So, first of all, what is important with this type of question, we've got to find the vector PQ. So let's just look at this GeoGebra representation of these vectors, okay, because we've got three components, we're in 3D space, so this is the X, the Y, positive Y, and Z axis. Okay, so we can see here, if we move this around a little bit, we can see the points P and Q. So here is the vector O to P, and here is the vector O to Q. And what we need to find mathematically, what is the vector P to Q? So what we need to make sure is that we're going to go PO plus OQ. So what we're doing is we're going from P to the origin, and then from the origin to Q, and that will be the same as going from P to Q. And that's what you always must remember when we're dealing with position vectors. So position vectors are vectors which are relative to a fixed point, in this case the origin. So it's very, very important that you actually write down this statement first of all. P to Q is equal to PO. It's P to O because you're going to the origin, plus OQ. And then you must realise that you're actually given the vector OP. So you must make sure that you change the sign of each of these. So this one will become plus 4, this one will become minus 3, and this one will become minus 5. And then you need to add, so a little note there to remind you to change the sign of each component, and then you just add this one, because this is the vector O to Q. 3 minus 4, 2. Then it's just simple arithmetic. 4 plus 3 is 7, minus 3 plus minus 4 is minus 7, and minus 5 plus 2 is minus 3. Right, so that's the finding the vector PQ. Now we must find the unit vector which is parallel to PQ. So what are we doing there? We're finding a vector which has a length of 1 unit. So to do that, and this is the symbol for unit vector, you write down the vector and you divide the vector by its magnitude, and that makes sure that you have a unit vector, i.e. a vector of length 1. So we're going to have to find the magnitude of this. So we do 1 over the magnitude, so it's going to be the unit vector parallel to PQ is going to be 1 over the square root of 7 squared, and then be careful when we put square root signs in here with minus signs, because you really should put them in brackets, minus 7 squared plus minus 3 squared, and then all we need that is multiplied by the actual vector itself, which is 7 minus 7, 3. Right, when we work this out on our calculator, most modern calculators will give it in third form. We're going to get 1 divided by the square root of 107, and that third simplifies, we leave it like that, times the vector 7 minus 7, 3. And that's our answer, or we could write this as a square root of 107 over 107 times our vector. Right, now we have to find a vector with magnitude 5 units parallel to PQ. Well, that's easy. If this is a vector of 1 unit, if we want a vector of 5 units, then all we need to do is multiply it by 5. So we have 5 times the unit vector. So 5PQ will be 5 over 100 square root of 107, 7 minus 7, 3, or 5 root 107 over 107, 7 minus 7, 3. And I will put the GeoGebra app that I've used in the notes of this video. Okay, I hope you've understood, and I thank you very much for watching.